Mushroom research advances constantly, and the great discoveries may be around the corner. Unfortunately, life in a mushroom farm is always busy, and it's hard to stay up to date. Specialized scientific journals don't help due to technical language and frequent paywalls. Our mission is to bring the latest discoveries on mushroom science to the industry professionals and the mushroom people. Ladies and gentlemen, please welcome to the new episode of the Mycelium Digest.
Welcome to episode 7 of the Mycelium Digest. We're the podcast dedicated to bridging the gap, bringing the latest mushroom research right from the labs directly to your farms. Today, we're tackling a really crucial subject, I think, for anyone involved with mushrooms, cultivating them, processing them, or just enjoying them. We're looking into their hidden nutritional power. Specifically, we're focusing on compounds called sterols, and importantly, how different preservation methods can dramatically change these compounds. We'll explore why these tiny molecules matter so much, and what actually happens when mushrooms go from fresh off the farm to preserved in a jar or dried in a bag. Just before we jump in, a quick note. If you happen to be watching us over on YouTube, we'd love it if you hit that subscribe button and maybe give us a like. It really helps. And for all of you listening on your podcast app, please consider following the show and leaving a rating. Oh, and sharing this episode on social media. That's huge for us. It helps us reach more folks in the industry. So please do spread the word if you find this valuable. Okay, let's get into it. Mushrooms.
They're definitely more than just a tasty topping, wouldn't you say? We often think of the common button mushroom, Agaricus bisporus. It's everywhere, the most consumed worldwide. It's a saprophyte, breaking down organic matter, and hugely popular. I read somewhere that in Germany, consumption is nearly 2 kilos per person each year.
That's right. It's incredibly popular. But beyond just being tasty and versatile, there's a deeper nutritional story. We know they're good for protein, good for fiber, and pretty low in fat. But what's fascinating, and maybe less known, is that they are surprisingly rich in these specific compounds called sterols.
Sterols. Okay, so what exactly are they in simple terms? Especially if mushrooms are low fat.
Right, it seems a bit contradictory. Sterols are organic molecules, structurally similar to cholesterol but found in plants and fungi. They're vital for cell membranes and other functions. And even with low overall lipid content, mushrooms pack a punch with specific sterols, and these are linked to positive health effects. Now, here's where it gets really interesting, particularly concerning vitamin D. One specific sterol, ergosterol, and a few others like it, sometimes called 5,7 sterols. These are provitamins, precursors.
Precursors meaning they turn into something else.
Exactly. Ergosterol is the precursor molecule for vitamin D2. The body, or even UV light, can convert it. This is incredibly important news, especially for vegans or those on plant-based diets. Mushrooms become arguably the most relevant natural source of vitamin D for them.
Wow. Okay. Do we know how much ergosterol we're talking about?
We do. For fresh cultivated white button mushrooms, the reported range is typically between, say, 400 and 800 milligrams per 100 grams of dry matter. That's quite significant. And ergosterol isn't just one of the sterols. It usually represents about 90% of the total sterols in these mushrooms.
90%. So it's really the main player.
Absolutely. There are other minor sterols, things like ergosta 7022, dienol, lanosterol, maybe some others. But in button mushrooms, ergosterol is considered the only predominant end product of their sterol synthesis pathway. It accounts for at least 72% of total sterols, often more, as we said.
Okay, so it's valuable. It's abundant in fresh mushrooms.
Which leads to the next crucial question. How stable is it? If it's so important, does it stick around? And this is where the chemistry comes in. All these sterols in button mushrooms have at least one double bond in their structure. This chemical feature makes them inherently sensitive. They can degrade when exposed to heat and oxygen. It's a process called autoxidation. Think of metal rusting or food spoiling. And furthermore, those specific A5,7 asterols, the vitamin D precursors like ergosterol, they are also inherently unstable under UVB light. They can transform.
Okay, so they're powerful, but also quite fragile. You mentioned mushrooms themselves are perishable, quality drops fast after harvest, and if less than half are eaten fresh, that means most go through some kind of preservation, right? Which seems like a potential problem for these fragile sterols.
Exactly. Preservation is key for managing supply and reducing waste, but it introduces processes that could impact these compounds. Common methods are things like pickling in brine or drying. Of course, there's also cooling, modified atmosphere packaging, freezing, canning, lots of approaches.
And I imagine the preparation matters too, like chopping them up.
Absolutely. Cutting mushrooms, which is often the first step for preserving, dramatically increases the surface area. More surface area means more exposure to oxygen, more sites for physical and chemical reactions, and it can also boost the activity of enzymes naturally present in the mushroom. all potential routes for degradation.
So how much impact do these processes actually have? Has it been measured?
Yes, it has. There was a key study that looked into exactly this. Scientists used a technique called gas chromatography with mass spectrometry, or GCMS. Think of it as a very precise way to separate and identify different chemical molecules. They analyzed ergosterol and other sterols in fresh, dried, and pickled button mushrooms bought from German supermarkets.
And what did they find? Was there a difference?
A significant difference. Fresh button mushrooms averaged around 610 milligrams of ergosterol per 100 grams dry weight, plus or minus about 20.
Okay, 610 milligrams, that's our baseline.
Right. Now compare that to the preserved ones. Pickled products average only 280 milligrams, plus or minus 30. And the dried products, even lower, just 190 milligrams per 100 grams dry weight, plus or minus 20.
Wow, that's a huge drop. Less than half for pickled and roughly only a third for dried compared to fresh.
It's a dramatic reduction, yes.
So does this mean the whole sterile profile changes? Does ergosterol lose its dominance?
Good question. They looked at the relative contribution, too. In fresh samples, ergosterol made up about 87% of total sterols. In the dried samples, interestingly, the proportion was quite similar, around 84%. So ergosterol was still dominant proportionally, even though the total amount was much lower.
Okay, so drying reduced everything somewhat evenly.
In terms of proportion, yes. But pickling was different. In pickled products, ergosterol share dropped significantly to about 78%. So for pickled, you lost more ergosterol both in absolute terms and as a percentage of the total sterols remaining.
And did other sterols increase to compensate?
Well, the relative contribution of some minor sterols, like ergosta 5,7-dianol and ergosta 7-enol, did increase slightly in the preserved samples, especially pickled. But, and this is crucial, the actual content, the absolute amount of these minor sterols was still lower in preserved samples compared to the fresh ones. So you're not gaining other sterols, you're just losing ergosterol faster than the others in some cases. Overall, sterol content is down.
Right. It really points to significant degradation happening during these preservation processes. We really need to understand why. What's causing this loss?
Exactly. Understanding the mechanism is key. The fact that ergosterol levels dropped so much suggested the degradation wasn't just a simple light-induced change. Researchers suspected degradation was likely happening, perhaps in the side chain of the ergosterol molecule. And interestingly, the loss seemed quite severe regardless of whether it was drying or pickling, suggesting maybe a common factor or sensitivity.
So what did they test next to figure this out?
They ran some stability experiments, and this is where things got quite revealing, maybe even counterintuitive at first. They took fresh mushrooms and heated them in a commercial brine solution, like you would for pickling or canning, up to about 90 degrees Celsius for an hour.
Okay, so simulating the heat processing step.
Precisely. And the result? There was virtually no immediate impact on the ergosterol level. The recovery was around 100% with an experimental error.
No impact. But the preserved products had much lower levels. That seems odd.
It does initially. It suggests that the high heat itself, for that duration, isn't the main driver of the loss seen in the final preserved products. So they looked at another factor. What if it wasn't the heat, but something else happening over time? They tried storing fresh mushrooms in the same brine solution, but this time at room temperature, around 20 degrees Celsius.
So no high heat, just sitting in brine.
Right, and under those conditions, the ergosterol level dropped substantially down to about 60% of the original amount compared to the fresh reference sample.
Okay, that's interesting. So room temperature storage in brine caused significant loss, but high heat didn't, at least not immediately.
Exactly. This strongly points towards enzymatically induced degradation. Enzymes naturally present in the mushrooms are likely breaking down the ergosterol at these lower temperatures. The high heat in the first experiment, that 90 degrees C, probably deactivated these enzymes very quickly, thus preserving the ergosterol during the heating phase itself.
So the enzymes are the culprits and heat stops them. That makes sense.
It seems to be a major factor. To explore stability further, they then did experiments using pure ergosterol standard solutions without the mushroom matrix. They stored these solutions at both 4 degrees Celsius refrigeration and 20 degrees Celsius room temperature for extended periods, some in clear glass, some in amber glass to block UV light.
And what happened to the pure ergosterol?
The content dropped steadily over time at both temperatures. After 60 days stored at 4 degrees C, the ergosterol content had fallen to between 22% and 28% of the initial amount, a loss of over 70%.
Like even refrigerated, wow.
Even refrigerated. But at room temperature, 20 degrees C, the degradation was much, much faster. After just 30 days at room temperature, the ergosterol level plummeted to only 1% to 3% of the initial amount, almost completely gone.
Goodness, that's incredibly fast, so temperature is absolutely critical.
Absolutely. The results showed temperature had a far stronger impact than protecting the solution from UV light using amber glass. The degradation followed what's called first-order kinetics, and the rate was about 6 times faster at 20 degrees C compared to 4 degrees C. They also identified 7 new degradation products, DP1, DP7, forming as the ergosterol broke down. And significantly, the most abundant one, DP2, was also detected in several of the commercially preserved mushroom samples they had tested earlier.
That ties it all together nicely. It really feels like an aha moment, particularly for producers. It means processing conditions and storage temperature are paramount.
Precisely. It suggests that how quickly mushrooms are processed after harvest, the thermal treatment used, and the temperature they're stored at afterwards all play a critical role. And the study found some real-world evidence for this too. They analyzed 2 specific canned button mushroom products that, surprisingly, had comparably high ergosterol content, much higher than the average preserved sample.
What do they attribute that to?
The strong hypothesis was that these particular mushrooms were processed immediately after harvest. Minimal delay. This would have minimized the time for those enzymes to act before the heat treatment deactivated them. It really reinforces the conclusion. Thermal input, controlling enzyme activity, and ongoing storage conditions are crucial for preserving ergosterol.
Okay, let's bring this home. What's the bottom line here for everyone involved, the growers, the processors, the consumers? How does this lab research translate to the farm and the kitchen?
Well, the main takeaway is pretty clear. Preserved mushrooms, while offering undeniable benefits like convenience and longer shelf life, generally provide significantly less ergosterol than fresh mushrooms. This has a direct impact on their nutritional value, specifically their contribution as a source of provitamin D2.
So for producers, the challenge is clear.
Yes, it really prompts the question, how can processes be optimized? Can immediate processing after harvest become standard practice? Can temperature control during preservation and storage be tightened? These factors could make a real difference in retaining nutritional value.
And for those of us eating them?
For consumers, it highlights the superior nutritional benefit, at least in terms of ergosterol, of choosing fresh mushrooms when possible. But it also encourages us to be mindful. When we choose preserved options, understanding that the preservation method and storage likely affect the nutrient profile is important. It's not that preserved are bad, but their profile is different.
It really highlights that trade-off, doesn't it? Convenience versus potentially lower levels of certain key nutrients. It makes you wonder, what might future innovations look like? Could we develop preservation techniques that better protect these sensitive compounds? Or maybe find ways to enhance the fresh product even further? Lots to think about. That brings us to the end of episode 7 of the Mycelium Digest. We really hope this exploration of mushroom sterols has given you some valuable insights. Understanding their importance and how preservation impacts them is key, whether you grow, process, or just enjoy mushrooms. And remember, your engagement really helps us continue doing this. If you found this useful, please subscribe and like us on YouTube. Or if you're listening on a podcast platform, a follow and a rating would be fantastic. And please do share the episode on social media. It helps us reach more people in our community. Thank you so much for joining us today. We look forward to bringing you more cutting-edge mushroom research next time on the Mycelium Digest.